Right. In this question, they're asking us to find VB, IE, IC and VCE. Right here, this question also from voltage divider method. You can see it. Voltage is divided by using 4 kilo ohms and 1 kilo ohms. If you have done other questions, this type of questions, then you know. If this is the first question, still you can go through with this guide. You will understand it. Right here, the potential they have given as 25 volt, just as potential here. Right, first question they're asking us to find VB. Right, we can apply voltage divider method because the potential here 0, potential here 25. So if we can find the potential of 1 kilo ohms and 4 kilo ohms, we can find the potential here, that is equal to potential at B. Right, now we know potential ratio is equal to resistance ratio. Right, so if V1 and V2, so resistance ratio 4:1, so we have to get the fractional value 4/5. We add these two as the denominator, then 4 1/5. Then what we have to do is we have to multiply this 25 value to find the potentials. So into 25 into 25, so here we get 20 volt and here we get 5 volt. Now we know the potential here 1 kilo ohms will keep 5 volt and this 4 kilo ohms will keep 20 volt. Since the potential here is 0, the difference is 5 volts, the potential here it has to be 5 volt. That means we have VB that equals to 5 volt. Right, moving into IE. Now we have found potential here. Potential at this point is 5 volt. So current goes through this junction, BE junction, and we should take this transistor, silicon transistor. So the potential difference, whereas VBE potential difference is 0.7, that you know, right? Then VB minus VE is 0.7. So here we have got B as 5, so VE equals 0.7, so we get VE as 4.3. Right, so potential here it's 4.3 volt now. Right, now we need to find the current through 1 kilo ohm. So let's apply V equals IR. V equals IR for this 1 kilo ohms resistor. So V 4.3 volt, I that's IE, and the resistance across is 1 kilo ohm. So 1 into 10 to the power 3. So we get IE as 4.3 into 10 to the power minus 3. That means 10 to the power minus 3 means milliamperes. So 4.3 milliamperes, and we have IE value. Right. Moving into the question, they're asking us IE and IC. Right. Now, small problem. To find IE, let's see what are the equations we know. IE equals IC plus IB, and beta equals IC over IB. Here IB is this current, and we cannot find IB current because no data is given for that, no resistor is given, no anything. And to find so we cannot find IB, or else beta also that is not given, voltage gain also not, but current gain is not given. Right, in these cases, you know what we have to do is we have to take IE approximately equal IC. So you know the answer now. We have to take IE approximately equal to IC. That means IC equals 4.3 milliamperes, just as IE. Right. Last one. VCE, potential difference across C and E. Right. VE, of course, we know 4.3 volt. VC, to find potential at C here, right, we know potential here it's 25 volt. right? If we can find the potential difference across 2 kilo ohms, we have Vc. So what we have to do is we have to apply again V equals IR for this 2 kilo ohms resistor. So we have found 4.3 milliamperes, 10 to the power minus 3, that into kilo ohms, 2 kilo ohms. So 10 to the power minus 3 this and cancel off. So we get 8.6 volt potential difference. So then the potential at C it has to be 25 minus 8.6 volt. So we get 0 0.4. Then we get 20, 16, 15.4. 16, it's 16, right? 16.4 plus 6, 17, 8, yeah. 16.4 volt, right? That means that is C. So it's 16.4. So the difference is VCE. Let's take the difference 1 here. So 12.1 volt is VCE. Now we have all the answers.